This is a pre-built version of the application. So we will start with a high-level overview of the code. So this class creates and populates dataset tables, and currently we have two: an apartment review table and an electric car review table. And this class create and populates hard-coded two-dimensional arrays datasets. So it has to do with hard-coded data, and same thing. Currently we have two: an apartment review and an electric car review dataset, and we can add or remove additional ones here. So this one has to do with data coming from the database, and this one with hard-coded data, and this one with data coming from file. So here we have .csv files, and this is what they contain. So we have an apartment review file and an electric car review file. So we have three places to get the data, either from hard-coded data, or from the database, or from file. And this class prompts the user for the file table or hard-coded data source name. So either one of those three. And it obtains and returns data as a two-dimensional array from file, from table, or from hard-coded data source. And this for data coming from the database, and the name of that database is data.db. And we are using an SQLite database. And this one is for data coming from file, and the name of the directory where we have those files is data. And this class handles all data display functionality. And this one contains additional matrix functionality, and we are using the commons mass library to do matrix operations. So we added to it a divide and a sum and a square root and a square methods. And this class contains k nearest neighbors functionality, and here we are using min-max normalization. So this class drives the application. So it has a main method, and it prompts the user for data source type, either to use a hard-coded or a database or a file data source, and it predicts a matching sentiment using k nearest neighbors. And before doing a quick demo, Let's go ahead and delete the existing database and create a new one that will contain those two tables. And we'll go with data coming from the database, and we'll pick the apartment review data. So we have this data for apartment reviews with those three features. So rent in dollars, and size in square feet, and distance to downtown in miles. So it's X1, X2, and X3. And this indicates if the reviews for each one of those apartments has been positive or negative or neutral. And X1 prime is normalized rent, and X2 prime is normalized size, and X3 prime is the normalized distance to downtown. So we calculate the normalized rent this way. We use X1 minus the minimum rent over the maximum rent minus the minimum rent. And we calculate the normalized size of the apartment here this way. So it is X2 minus the minimum size in here. Pick the minimum of those over the maximum size minus the minimum size. And same thing for the distance to downtown. So let's check the potential reaction for an apartment with this rent in dollars and this size in square feet, and this distance to downtown in miles. And we'll use the three nearest neighbors. So we end up with a tie vote, since this is negative, this is neutral, and this one is positive. And here we are calculating the Euclidean distance. And here we calculate the normalized input features. So this one is for the inputted rent. So it's 1,000, input 1, minus the minimum, X1. So it's this one, 633 over the maximum minus the minimum. So the maximum is this one. So this is normalized input for rent, and this one is for size in square feet, and this one is for distance to downtown in miles. And let's see what happens if we have the same inputs. except we'll use 4 nearest neighbors. So we end up with a negative sentiment prediction. So we have this one is negative, this one is neutral, and this one is negative, and this one is positive. So 2 negative out of 4, and the other 2 are positive or neutral. So we end up with this. And let's pick up data now from file, and maybe so here for electric car reviews we have 4 features. We have the price of an electric car in dollars, X1, and we have the driving range in miles, this is X2, and we have the battery size in kilowatt hours, this is X3, and we have horsepower, this is X4, and this is based on reviews. Either we got negative or positive or neutral reviews. And same thing, those are the normalized values for price, driving range, battery size, and horsepower. And let's try to predict sentiment for a car of $30,000, an electric car of $30,000, and maybe 300 miles driving range, and maybe 100 kilowatt hour battery size, and maybe also 300 horsepower, and we'll use the 3 nearest neighbors. And same thing, we got a tie vote, unable to predict sentiment. So we have this one is positive, this one is negative, and this one is neutral. So maybe let's have the same thing, but use 4, maybe 5 nearest neighbors. And we have a positive sentiment prediction. So we have this one is positive, this one is negative, and this one is positive, and this one is neutral, and this one is positive. So 3 positive. Now the source code will be available for download, and a members only version will be available for viewing by channel members at the software engineer level and above, and it includes step-by-step coding.